All right, I will introduce our moderator, and other introductions will be handled by Chris. Chris joined ITS in 2023 following a distinguished 16-year tenure in the United States at the United States Naval Academy as an associate professor in the Electrical and Computer Engineering Department. And in June of 2024, he was elevated to ITS Theory Division Chief. Over to you, Chris. Thanks for being here. Chris?
Yeah, and as of April 30th, I became the Acting Measurements Division Chief. So I got to wear two supervisory hats now. So yeah, thank you everybody. I think we've got a really dynamic panel. We had a lot of good discussions going in some of our preparatory sessions. But basically we're talking about dark and quiet skies. And as a bit of an opening statement, or as a way of an opening statement, as the humanities, as our presence in space accelerates, the sky is becoming busier and brighter, both from an optical perspective as well as a wireless spectrum perspective. Rapid deployment of large satellite constellations that are going to be essential for global connectivity and commercial innovation has created a growing tension that we've seen in this conference, with efforts to preserve shared access to the night sky. Both optical and radio astronomers face increasing interference from reflected light and electromagnetic emissions, and Earth observation systems grapple with degraded measurement accuracy. These challenges are compounded by growing concerns about orbital debris, which we've also seen discussed at this conference, and the sustainability of single-use satellite deployments. So what we're going to try to do in this panel is explore the increasingly urgent question that how do we sustain space as a shared resource, both balancing commercial growth with the preservation of critical scientific, environmental, and public interests. And we're going to examine competing priorities and trade-offs that are at the heart of the issue. How can science and market forces align to protect our dark and quiet skies? And we've got a number of very knowledgeable people on the panel here, just by way of a quick introduction. So we have Ashley VanderLey as an independent astronomer today. We have Jessica Heim from the University of Queensland, a PhD student, is that correct?
Yeah, and
we have Kelsey Johnson from the University of Virginia. We have Zack Donohew from the University of Colorado Boulder. And Paul Kolodzy. Paul, what hat are you wearing today?
Logos.
Logos.
Space Services.
So I'm going to allow the panelists to, or ask the panelists to provide a brief opening statement, and then we'll start going into discussion. So Ashley, you're up first.
Sounds great. Thank you. I really appreciate the invitation to be here, and Keith for continuing to twist my arm. It's fantastic. So I am here in my personal capacity, but I wanted to share some of my personal reflections on this topic, both working at the National Science Foundation for 8 years, also serving as the US lead to the ITU for Working Party 7D on behalf of the State Department, also serving as a board member on the American Astronomical Society. And so just kind of observing the issues and ways that we can actually work together to solve this problem and continue to explore and solve the really important problems that David pointed out. One thing I wanted to point you all to, if you did not see the news this week, the Vera-C-Rubin Observatory had its first look on Monday. Absolutely fabulous images. If you go to rubinobservatory.org or the skyviewer.app, you can actually explore these images yourself. The reason I wanted to point this out is they're absolutely just beautiful and stunning. So it would take over 400 high-definition televisions for your eye to take in a single 15-second exposure from the Rubin Observatory. It's 8 square degrees, which is about the area of 45 full moons. So you can kind of see how big this image is. And it's not new, the fact that we know that space that otherwise looks completely empty is full of stars and galaxies that we can learn from. We learned this from Hubble. But Hubble, taking about 1.6 million images, only has observed about 1%, far less than 1% of the whole sky, where Rubin over a 10-year period is going to have this exquisite ability to learn from the sky over 50% of the sky, so creating a 10-year movie. So I really wanted to say thank you to the satellite operators. One of the big things when we think about space as a resource, we've been thinking about the impacts to radio astronomy, but also the impacts to optical and infrared astronomy. So in optical astronomy, astronomers are used to removing satellite streaks from their data. So one of the big challenges was to just ensure that the brightness of any particular satellite was not so bright that it caused nonlinear effects in the largest CCD camera ever created for Rubin. Because if that happens, you've actually kind of ruined the entire image. But if it's actually faint enough, which we determined originally, we thought it was about 7th magnitude, which is about the limit that your naked eye can see. We're kind of moving that down probably to 6 or 6.5 magnitude. So there's ways of doing that, but I wanted to really point you to that. I think it's absolutely beautiful, and I think you'll enjoy exploring those images. Also wanted to just point out that the Rubin Observatory is going to be detecting many asteroids. So currently we know of about 1 million asteroids in the asteroid belt. It's a big concern for the American population and the whole world if we have a dangerous killer asteroid of a certain size come and hit the Earth. So it's actually a congressional mandate to discover and characterize asteroids of a particular size. About 1 million are known. They expect in the next couple of years, Rubin is going to be able to detect and characterize millions. So we're looking at probably 5 million more discovered. So really good characterization. But that also shows that objects in space are not necessarily destroying our ability to see through that asteroid belt into the broader. We just need to know how to characterize and remove it from the data. So I did want to highlight that as a good that astronomy provides to all of us. Yesterday, there was a lot of discussion as well about sort of economic inputs and things that we all benefit from. And so I think many of you know this, but I did want to highlight from the radio astronomy perspective, one thing that radio astronomy has provided that is not fully appreciated is contributions to understanding how the Earth is oriented in space. So we all rely on GPS, but what does GPS rely on? We have to know very precisely how the Earth is oriented. And if you have star trackers on your satellite, that's great, but stars also move. And so it actually takes observations of very distant galaxies and the black holes at their centers, which do not move on the timescales that we care about, to get the most accurate position for the Earth. So this is one thing that we do with our radio telescopes, including the Very Long Baseline Array and an international array of telescopes, is just observe black holes over and over again to establish that celestial reference frame so that we can have the high precision GPS that's needed. And so, for everyone that says, why should I work together to help protect radio astronomy observation and ensure this is possible, it's because you're all relying on that fundamental reference frame for the satellites that you operate and also the cell phone in your pocket. So that's really important, and I wanted to highlight. So some of the frequencies that are currently used are S and X band, which is sort of 2 to 4 gigahertz and 8 to 10 gigahertz. Folks are looking to move up to higher frequency bands to be able to avoid some of the interference. A couple more quick comments I just wanted to highlight. One thing that I think is really important, folks have used modeling for a long time as sort of the way to determine if compatibility is possible. And we really think it's important to go from modeling to testing. Essentially, let's use the scientific method. The model is your hypothesis. Now let's test and see if that works. And oftentimes you'll find that the models are kind of toy models. They make a lot of simplifying assumptions, but in the real world, we might be able to actually find better solutions, as was referred to yesterday. One example, folks asked about dynamic sharing as it comes to satellites, and we have some fantastic news. Stuff has been published by a number of astronomers, including NRAO, and in collaboration with SpaceX, and we're looking to work with multiple satellite companies on this, but it's called the Operational Data Sharing System. So initially, looking at sort of downlinks for the fixed satellite service from 10.7 to 12.7 gigahertz, satellite operators have to coordinate with the National Science Foundation. There's a rule, it's US 131. It's very generic what that coordination means. There's a tiny, tiny radio astronomy band. But astronomers actually care about the entire bandwidth. They observe from 1 to 115 gigahertz wherever the physics and the science takes them. So there's the most important bands that are protected, but you do want to have access to the sky as much as possible everywhere. So initially we thought, okay, let's say no downlinks in the whole state of New Mexico. Will that protect the Very Large Array where David visited? Well, it turns out that does not protect as well as if you can actually dynamically protect with boresight encounters. So if you know precisely where the telescope is looking and where the satellite is pointing, and you can do very precise coordination, it turns out you can bring in the satellite service within just a mile or two of the telescope. And so you're able to do your scientific observations and provide service. And so if we'd proposed that initially, it would have sounded crazy, very, very complicated, kind of a machine learning, kind of machine to machine. But this is now fully implemented at the VLA, and they're doing hundreds of maneuvers every week. SpaceX, and there's a number of other satellite companies that are working to implement this, and this is beginning to kind of get rolled out more broadly. So I think this dynamic spectrum sharing is beginning to work, and we see the fruits of that. So I wanted to highlight that. So with that, that was kind of the main points I wanted to make, and I really appreciate being here. Thanks.
All right, sure. Thank you. That was a great introduction. Jessica, what are your thoughts?
Yeah, so just a few intro ideas I wanted to throw out there. So I'm a PhD candidate and adjunct research fellow at the University of Southern Queensland, but I'm based in Minnesota as I'm doing most of my work remotely. In addition, I've been a part of the American Astronomical Society's Committee for the Protection of Astronomy in the Space Environment, or COMPAS, for several years, and I also co-lead the Community Engagement Hub of the International Astronomical Union's Center for the Protection of the Dark and Quiet Sky from Satellite Constellation Interference, which is thankfully abbreviated IAUCPS. I have an interdisciplinary background involving environmental science and the humanities, as well as both scientific and cultural aspects of astronomy. My research focuses on effects of human activities on both Earth and space environment, and delves into the complex relationships that humans have with both the skies above and the land below. The multifaceted nature of dark sky and space sustainability issues is such that they cannot be understood solely through any single disciplinary lens. It is essential to consider not only the technical, economic, scientific, and legal components, but also to recognize that there are broader considerations as well. When I was invited to speak at this event, I was asked to discuss ethical and cultural aspects of dark sky issues. As I also have a background engaging with Indigenous scholars and Indigenous perspectives on these issues, I was also asked to talk about dark sky matters in this context. While every community is unique and has their own perspectives, one commonality across many Indigenous communities is the fact that the stars and the night sky play a very important role in their knowledge systems and teachings. Also, many tribal nations are in locations that are remote and not currently well served by broadband internet access. The advent of internet service brought about by large satellite constellation is often seen as a good way to bridge the digital divide and to enable access to broadband in rural communities and tribal nations. And indeed, some tribes have utilized such satellite internet to better enable access to telehealth and other useful services. But the issue of internet connectivity is much more complex than simply creating a technology and then selling it to customers. There are many additional important questions to ask, such as, does the price this service is being offered for match the price that those who could use such a service are actually able to pay? Also, who owns the service, and have those who stand to be affected by unintentional adverse consequences, such as changes to the night sky, been consulted prior to the deployment of the service? Sovereignty is an area of central importance to Indigenous nations, but this is unfortunately something that is often overlooked by well-intentioned individuals coming from outside these communities. There's a long history of outsiders coming in to help communities with pre-made solutions rather than working collaboratively to find out what the community's needs and concerns are, and then working as equals to jointly create something of mutual value. In my conversations with Indigenous colleagues, one key theme that continually comes up is the importance of relationships. In that, if you are seeking to have meaningful discussions with these communities, whether it be about internet access, the importance of dark skies, or any other subjects, the most important thing to think about is the quality and nature of your relationships. In addition to the importance of building good relationships with people and communities, there are further relationships to think about when we consider the subject of space sustainability more broadly. We might ask ourselves, what is the nature of our relationships, not only with each other as humans, but also with the Earth, the night sky, and the larger space environment? To conclude, I offer that space sustainability ought not to be limited to topics such as reduction and avoidance of space debris and of the protection of dark and quiet skies. It must also include consideration of how growth in space activities stands to impact the continuum of Earth, night sky, and space environments. To truly be sustainable, it is important to consider the social and environmental impacts of the full life cycle of space activities, from manufacture to launch to the operational phase of missions through end-of-life disposal. By thinking in such a holistic manner, achieving long-term sustainability becomes more feasible and novel solutions can be found. I look forward to the rest of the panel and continue to discuss this with everyone.
All right. Thank you, Jessica.
All right, good
Kelsey.
morning. Just by way of background, I want to share that I've been serving on the Committee for Radio Frequencies of the National Academy for the last 6 years. I'm about to rotate off that, and also just finished my term recently as president of the American Astronomical Society. So I've been embedded in these policy issues pretty deeply for a long time, even though I bring my astronomer sensibilities to the table. So I realize that many of you are actually playing like multi-dimensional chess here in terms of policy, and I'm coming to the table with like tic-tac-toe, like not even checkers. And really all I'm armed with are my astronomer sensibilities. And so, I hope you'll forgive me for my naivete on some of these issues and maybe indulge me for a few minutes as I wax a little bit, maybe philosophically from my own perspective. I do want to say that as, someone who works at a public institution, I need to be clear that these are my own positions, right? Just as Ashley is here in her own personal capacity, these are things we have to be careful of in the public sphere. So as an astrophysicist, I spend a lot of time thinking about humanity's place in the universe. I don't think most people understand how small we are on the scale of things, thanks to Brad for, the little analogy with the sun. But I don't think most people understand how small we are, both in time and in space and in the grand cosmic story. So I take a very long view. I find myself thinking daily, what will generations from now, what will our descendants think about the decisions we're making today? In the discussions yesterday, it struck me, I don't know if it struck any of you this way, that we all seem to hold, or I perceive that we all seem to hold very different versions of what might be utopia. And I will admit, I may be the odd one out, which is often the case for me. So I just kind of own that and lean into it. I do wonder, has anyone watched The Expanse? Oh, you all lost your nerd cred right there. I no longer take any of you seriously. Okay. All right, well, this may fall flat if you haven't watched it. I tried to watch it and I had to stop. Not because it was bad, but because it was too accurate. And a version of The Expanse is actually where I fear that we're heading. So if that's not a spoiler for watching that and making you feel inspired, there you have it. I think it's fundamentally important in these conversations that we need to be honest and transparent about what we value and why we value it. If we can do that transparently and respectfully, I think we might be able to find even more common ground than we expect. But when we parse things through an ethical lens, and I say this as an academic who thinks about things like this, what that requires us to ask is what good is done and to what or whom, and what harm is done and to what or whom, especially in the long term, and on balance, which one wins out? If we're not asking those questions regularly, we are not acting responsibly. Now, it probably won't shock you that in my own value system, one of the most important things for me is, and one of the most important things I believe we can do in humans in our very small window of time on Earth is understand our place in the universe. That journey begins with the night sky. And since before recorded history, the night sky has been a common touchstone for humanity. It has inspired wonder, navigation, storytelling, science, and the list goes on. Astronomers have been watching humanity's access to the universe erode, and that rate of erosion is rapidly accelerating. I believe that on the trajectory we are headed, that within a generation, the night sky will be cut off from all of humanity, no matter where you are on the globe. And I think that is the tragedy of the commons unfolding over our very heads. Now, I want to swap hats for just a hot second because I do also have an appointment in religious studies and put that hat on for a little bit of a micro lesson. Much of our current framework for thinking about outer space is actually embedded in religion, and I think many people don't necessarily realize that. It's rooted in a papal decree from the 1400s called the Doctrine of Discovery. In 1493, it was Pope Alexander VI who issued a decree that justified European claims over non-Christian lands. The logic used in this decree was then embedded in Western colonialism, and the same logic today is showing up when people and actors assert rights to outer space resources, simply because they had the ability and the resources to get there first. Although, okay, not a legal scholar, but if we were to lean on the legal framework like first appropriation, and I don't think this would ever hold up in court, but I would argue the night sky should surely belong to astronomy as the oldest science and predating recorded history. The reality is space is not a blank slate, and to be sure, it is rivalrous, and it is shared, and it is consequential for all of humanity. I would argue we have to move beyond the inherited assumptions of dominance and entitlement, and instead build a future grounded in equity, humility, and stewardship. Because without that, I truly fear that it will only be a few generations before we are living in the expanse. And I don't think anyone wants that. And just watch it if you need to. And finally, the last thing I want to share, because this for me is one of my other core values, and I believe that most humans probably share this. Not everything of value can be owned, and not everything that matters can be measured in profit. And I'll end there.
All right, thanks, Kelsey. Zack,
Yeah,
what thoughts
thanks.
can you share with the panel?
Thanks, Chris. I'm going to approach this issue from an economics perspective, which you're kind of leaning into at the end there, Kelsey.
A little bit.
Yeah, I mean, yesterday we heard Patty talk about what a wet blanket engineers are at dinner parties. So let me see if I can convince her. Maybe the economists are instead, right? So I just walked through kind of an economic way of approaching this dark and quiet skies issue. So, like there are no solutions. There are only trade-offs here, right? The reason I say that because we're talking about a commons or an open access issue, and I would describe these problems as externalities, right? Satellite operators, people are not doing things maliciously, but their actions for their private benefit are having spillover effects on third parties, right? And so while they get to accrue all the benefits, the costs of their actions, some of them are external to their decision making. And if we were to stop them from doing that, then they would say, well, we would be harmed then by not being able to do our operations. And so in this sense, externalities are reciprocal. And it comes from a lack of well-defined property rights, right? Maybe we do want to, a first come, first serve. The astronomers were here first.
Hell yes.
You should have property rights to it, right? If someone wants to interfere with that, they should have to buy those rights from you. Well, it is society's responsibility to decide how we do assign those types of rights, either, and right now it seems to be in just a de facto way. And so economics is this, as Carolyn and Jennifer said yesterday, is the study and management of scarce resources. And so, 10 years ago, this was much less of a problem because there was just a little bit less scarcity, a little bit less of an externality issue. Increasingly, this is a bigger issue. So, from my perspective, maybe we'll talk about it a little bit later in the panel, is that it would be great if we could get a better understanding of a number, if we could assign a number to what kind of values we're getting from dark and quiet skies. Because when we can do that, then we can start to measure what that harm is. And then we can start measuring, well, what is the cost of that harm versus what might the cost of mitigation be? Right? David mentioned earlier that Starlink are doing things, right, to mitigate their effects, which is coming at a cost to Starlink, right? Either in loss of service and coverage for a little bit, or dimming their satellites. And so we can start to see what would be a really nice policy solution to this problem. But it's also been talked about, this is a global problem, right? And as we might expect, we could ask the United States to be best actors, to take certain actions to limit these externalities that we're creating. But this is also a global problem, which acts, as another layer to this issue. But it doesn't mean we can't lead by example and perhaps set some norms. So really happy to be on this panel and look forward to discussing this some more. Thank you.
All right, great. And Paul, do you want to finish this off?
Well, I'll try. Well, first of all, thanks for inviting me onto the panel. I mean, I think the last 2 days here, actually having a group that comes from the policy side, as well as the technical side, as well as the economic side, also from academia, from industry, and from government. It's kind of an interesting mixture that you actually can kind of put things all together and try to actually understand each of the perspectives and how we can actually address issues. Now, I'm going to come in from the technology side because that's sort of what I know. So I'll let the policy people, talk and teach me, and the economics people to teach me new things. But from an engineer point of view, we like to solve problems, right? That's what engineers do. You give us a problem and we try to figure out how to solve it. Most of the time we're talking about, in the sense of the topic for this conference, has been resource management, right? We have a resource that is finite, and the question is, how do we manage it? I actually take a different perspective to this. I think it is resource management, but I actually think the real problem is entropy. Okay? And in some sense, I'll do a shout out right away to Ashley, because she actually brought up this in some respects. We know not all interference or not all interventions are random. If you actually know where you're trying to sense or you're trying to transmit, then that lack of randomness gives you an opportunity to solve the problem. And so the shout out is how you actually work with SpaceX to try to actually solve that problem by reducing entropy, not making it a random act anymore, and actually trying to figure out how to exploit that. So let me kind of go at how entropy actually plays into this a little bit. When a resource is brandy new and it's lots of it, and you don't think there's not much that you can harm, you'll basically love entropy. Back in the 1960s, when we did launches, we had explosive bolts on the spacecraft. Boom, bolt went off. Why? There's lots of space here, lots of randomness here, not much in there, so why not, right? Not gonna harm anybody. Just adding a little bit of noise to the system. And then as time goes on and using that resource, the noise sort of kind of builds up. Now entropy becomes a problem, because now you can't get rid of it easily because it's random. If it was less random, you might be able to have techniques, as an engineer would, try to find a solution to taking out this randomness, and using something that isn't random, you can actually try to remove it or avoid it, or all the different techniques that you might want to use. And SpaceX is actually doing that right now, because when they do their launches, they try to make sure there's not this random noise going out there, meaning random bolts and whatever. Everybody's now trying to figure out a way of actually collapsing that entropy and trying to make it that you actually can do something about it. And so, in my opinion, that's what we want to do. We want to basically turn entropy into signals. And signals, in some sense, or non-randomness, has a chance of actually solving the problem. And I think there's a variety of engineering tools that we might be able to do to actually try to motivate some of this. One of them, and again, is I just talked about before, is in the object space, right? In the actual physical space. You want to simply try to find ways to try not to throw out small particles, but larger clumps that might be able to be reused, that can be deorbited, that can be used in other ways. In the RF, you want to have tight beams. You want to have low emissions. You want to keep things close in, so that way that others would know that there's not a randomness in the sense of intervention. In the optical, this is an interesting one, and I was looking at this a little bit over the last few weeks. Actually, Ashley, through a conversation we had at one point, actually brought this to my mind, which is we thought that maybe diffuse reflectors are good, but diffuse reflectors are random. Specular reflectors are not random. So if you actually knew when you were going to reflection or get signal, you might be able to do something about it. I'm not saying it's going to solve all problems, but at least gives you an opportunity to solve those problems. And so what I'm trying to wonder about, and this is again for the whole community to kind of get together, is how do you set up the proper incentives to push, to reduce entropy, to enable cooperation, and to enable more efficient use of it? At Logos, and like, we're trying to actually look into some of this, and we're trying to actually look at how we can actually enable synchronization between the satellites at a high way, at a very, very precise way. Why? Maybe cooperation in a sense of using basically distributed apertures for the astronomy community and things like this may actually take this randomness behavior of all these satellites working individually and try to bring them together in a coherent way, which again removes entropy. Thank you.
All right, well, thank you. So that's a great lead in to maybe a kickoff discussion for the panel. So the panel has expressed the need for preserving a dark and quiet sky for a variety of reasons. We've talked about over the course of the 2 days here about the desire for connectivity and satellites and the utility of space and satellite coverage. And so as a way of like thinking about these two in conjunction, like what are the key technology, environmental, and economic challenges associated with preserving the dark and quiet skies amid the growth of these commercial satellite operations, both of which we've seen over the course of the couple of days have economic and non-economic value? So who wants to kick us off?
Just very quickly, I like what Commissioner Gomez said yesterday, that one of the challenges was failure to ask questions. And we have found that when there is a discussion and people are engaging and asking questions, then the issues can be brought to the surface to find out, is there a solution? Because I think it's not all trade-offs. In some cases, there are solutions, but then on occasion, there will have to be trade-offs. So I do think that failure to ask questions, so having the environments like this very conference and continuing that so that we have a chance to share with each other and make sure that we can ask the appropriate questions and share with each other. But I think that is a big challenge. There's a lot of companies that come to NSF, for example, because they're required to coordinate, but then there's lots that have no requirement, but there's still things that they could do. So yet, how do you have those conversations? How do you ask questions? I think that's a big challenge.
Yeah, and NSF, National Science Foundation, for those that aren't aware.
I'll jump in with a few comments on this as well. First, I do want to say that I don't think all space companies are looking to like destroy access to the universe. That would be like a James Bond level villain kind of thing to do. I think most people are trying to act responsibly, and they're just not maybe asking the right questions. From my perspective, there are really two things that I want to call upon folks in the satellite industry to really be considering strongly. The first is with respect to radio emission. All the things that have already been said. Astronomers, we are trying to be good partners, right? We recognize, we're trying to find compromises where we can. One of the things we're trying to do is we have right now, at least, maybe not for long, we have a radio quiet zone, right, around the Green Bank Observatory, which is our way of saying, okay, at least give us access to this patch of the sky, right? So there's real importance, I think, to having radio quiet zones, which then enable, all the things you want to send down to Earth and other places. Because most humans that I'm aware of don't actually see radio light, so it doesn't interfere with most humans. And I know Ashley's been working a lot on radiodynamic zones, right? So that the more predictability we have, the less randomness we have, the more we can work on what to do with the telescopes if we can coordinate. And so that's the radio perspective. From the optical perspective, this is harder. Because we really do need the satellites. I don't know if you all speak like optical magnitudes in astronomy. For reference, that as Ashley said, the typical human eye can see between 6 and 7 magnitudes if you're looking out at stars, which is roughly, the North Star is a little bit brighter than that. But to date, folks in the satellite industry have really not been able to get the reflected brightness of satellites lower than that. Right, most satellites to date are brighter than the North Star when they're reflecting sunlight. And so that is a real serious issue, not just for observatories, you know, and Ruben just came online, it's gonna be a massive problem for Ruben, but actually for humanity. In the sense that, I don't know, this is one of those things, like if I ask you, how many stars do you think you can see in the night sky? And people would say millions. Wrong. It's actually about 8,000, depending on your vision. It's not really that many. And so when you think about the number of satellites that are being launched and predicted to be launched, and that when they're reflecting sunlight, they will be brighter than the North Star, it won't be long before we have more satellites in orbit by an order of magnitude than visible stars. And so we really, really need, my plea for industry is to double down on your efforts for how we can make the satellites darker and reflect less light. And the problem is it's not just optical light, which humans see, but then many of the mitigation strategies, if we damp down the optical light, then they start radiating infrared light, and then we have another problem. And so we just keep kind of kicking the can down the road. But the extent to which we can partner with you on that and work on getting the satellites fainter will help all of this, and we'll stop being squeaky wheels and complaining at all of your meetings.
Paul.
Yeah, going down that path, and I like what you were just saying, Kelsey. When a resource starts getting used, when you have this collision of different groups trying to use it, it's the time now, like with this kind of group getting together, is to start figuring out a common language and starting to learn about each other. So it's the collaboration before you try to launch, before you try to do something else out there. And so it's always a good way to actually start. I mean, I was just reading, some of the papers, and even the language that we use is different. It's no right or wrong, but it's actually getting the communities together and start talking about what are the challenges that they're having and what might help each other versus one community telling the other community how they're going to solve their problem. It might be useful to collaborate to discover what is the mechanisms to actually try to help each other. And again, that's why I applaud what this community is trying to do, is this is the first time of trying to bring them together and start doing about it. I mean, just as an example, I was reading some of the papers. Of course, everything is done in Jansky's.
Sorry.
No, you were, as you said, you were there first, okay? Is that Jansky is a real term, and I looked it up and I started looking at translation into the terms that I'm used to. That's just the first step. I mean, once you start getting a common language, then you have a mechanism to actually start trying to figure out what are the chances of how, there's some techniques that we know about, there's some techniques that you know about, and how do you actually bring those techniques together?
Chris, do you want to share your little factoid about how sensitive radio astronomers are?
Yeah, so this comes up frequently. So I've been working with Ashley in the National Radio Dynamic Zone effort. And the translation is a little bit wonky because Jansky is a power density. It's watts per hertz per square meter, right? So you have to make some assumptions about the size of your antenna and your bandwidth and things like that. So, but as a back of the envelope engineering calculation, a radio astronomy telescope, something like the VLA, the Very Large Array, or the Green Bank telescope can measure or record a signal at about -300 dBm. For most of us in the commercial world of Wi-Fi and cellular signals, a strong cellular signal is about -80. A strong Wi-Fi signal is about -80 dBm. So you think about, it's a logarithmic scale, so it's many orders of magnitude more sensitive than what most people are used to with a Wi-Fi device and with a cellular phone. Again, caveat that with, there's a lot of assumptions that go into that -300 dBm number, but roughly speaking, that's, when a radio astronomer says, I can measure a cell phone signal on Pluto, yes, they can. Well, this has hopefully stimulated some great thoughts in some folks in our audience, and let me ask if there's any audience questions that we want to kick off the panel discussion with. And I see a student right here, ready to go.
Hi, my name's Jack Cashin. I'm going to be a fifth-year aerospace engineering undergrad. I grew up in a pretty rural place in Colorado, Steamboat, and I could drive 5 minutes by my house and go look at the night sky. And I have like pictures that I've taken from that. If you want to see those, it's like asking pictures of your baby, but So, like, astronomy for me was a huge, important part of why I got into aerospace. I'm getting an astrophysics minor. I have a tattoo of a constellation on my body. Like, that's how much I care about it. But I just looked this up. According to the CIA, 83% of people live in urban areas. And how do we get people who don't have access to the night sky more because of, I guess, the light pollution, which isn't really what this is about, like caring and understanding why having some dark and quiet skies is really important? Because you mentioned the GPS issue, and it's like we mentioned yesterday, I don't need GPS, I have an app, and it's like, that app uses GPS, please inform yourself. But yeah, like, how do we get more people to understand, especially now that their general night sky usage is blocked out from like light pollution?
Yeah, I can start with that because I have a background with ground-based light pollution issues as well. Yeah, like what you're describing is a major issue. And just like talking to so many people, telling me stories about, oh, when I was a kid, this is how the dark sky, and like even my own personal experience in my lifetime, seeing the impacts of ground-based light pollution. Yeah, it's a huge issue. And I did some research looking at dark sky advocates and how they were able to successfully get in better lighting. So like, for everyone to keep in mind, we don't necessarily have to be creating so much light pollution. Like, we could light our cities and we wouldn't have to lose the beautiful view of the universe. It wouldn't look like the middle of the wilderness when you're in downtown New York City, but it doesn't have to be as bad as it is. But I think that is a challenge, is getting that personal connection, I think, is really important. Just when I used to work in a planetarium, and we would simulate what the night sky looked like, and we'd have these third graders, and they'd come in and they'd be like, wow, they had like never seen what that looked like in real life. And I've talked to people who had like gone to a planetarium, and they're like, oh, I thought that was made up till I went out to a rural area. And I've just heard so many stories of people who like described this emotional experience they had with the night sky, and that inspired them to go into engineering or science, or not necessarily astronomy, but some other science or space field. And I guess my personal thought on that is just like, it's really important to design our ground-based lighting better so people do have access to that. Because I think it is difficult for people to connect to something that they don't have personal experience with. It's like a quote from a book, I can't remember the author right now, but he was like, how do you get people to be concerned about a forest if they've never seen a tree? And so I think that that's like an important part of like, science education, K-12, giving people opportunities to be able to have some degree of experience with that, or people aren't going to care about something that's just abstract.
I want to, Jack, if I can jump in here. First, I admire your commitment with the tattoo. I'm looking to get Euler's equation myself. I think this is, wow, that got more laughter than I ever thought it would. Maybe I should get it before I leave on my flight. I know, I've seen people with Maxwell's equations, and that is commitment. So that gauntlet is thrown, Jack. So I founded a program called Dark Skies, Bright Kids like 15 years ago with actually this very mission. And I wrote a book called Constellations for Kids with this very mission. And I think the real problem is people don't know what they're missing if they've never seen it. And so I think it's incumbent, we do everything we can as astronomers to try to get the voice out, but we're like, I don't know what small percentage of the population. We really need it amplified by other people who are not us. We need you to go and do dark sky tourism. Like, if you've never actually seen a truly dark night sky, like, that is your homework assignment, and I'm a professor, so I get to give that to you, right? You need to go see a truly dark night sky to understand what humanity is losing access to. You need to take your kids or your grandkids or your neighbor's kids, or kidnap some kids off the street, like, I don't even care, and bring them to a dark sky location so they've seen it at least once in their life before it disappears. Because if people never see it, this is exactly your point, they don't know what they're missing.
Let me approach Jack's question from Quiet Skies perspective. How do you get the public to care? And there's some market-based ways that this happens. Particularly, we heard from Ms. McGrath yesterday talking about the loss of data quality. And so if we're a little less precise in forecasting hurricanes, if we're a little less precise in our irrigation scheduling, well, those things have value, and insurance markets do a really good job of incorporating those risks. And so if they don't have as good quality, then those models aren't going to work as well, and you're going to see that reflected in the prices of things like insurance. And so everyone will be affected by that. Whether they connect the dots between those higher insurance prices and a reduction in data quality, maybe not, but the market is thinking about these things.
Anybody else? I see another question. I saw this hand go first.
I'll be quick. I'm on occasion offshore sailor, and I always volunteer for the midnight to 4 a.m. just for that. I do want to make a comment on Zack. Not everything is really ability to price intellectual property. It's just not. I mean, a lot of art is really priceless. So when you look at future, what you want to call it, entropy or not, future cloudiness for the radio telescopes and optical telescopes, you're preventing future knowledge. It's like, how do we acquire future knowledge, and how would we price future knowledge that we don't even know? So certainly, I'm a commercial space guy, so I get it. And we're on the weather side, so I get that. I mean, the precision knowledge of this atmosphere of this planet, because we're an undersampled system right now, to be able to do better forecasting and better knowledge of climate research. The comment that I'm just making is I'm agreeing with Kelsey for not to be good denizens of space across the board. And you can't really price everything, and you're just not going to happen. And certainly I agree with Ashley on, oh my God, those pictures are great. So you really, really have to see it. And it puts things in perspective, the human perspective. And back to Kelsey on the 1400s or so. It's really before that. It's really Joseph Campbell and the myth and the skies and the gods. And hey, it's wondrous. So I just have a hard time bringing it down to economics, because it's just not. And I know that wasn't your push, but I just wanted to make that as a comment than anything else.
Oh yeah, I appreciate that comment very much, and agree with you. And I thought, Kelsey, I thought you were going to punch my arm when I said that. I was prepared for that.
Well, how else are we going to sell it to people if we don't try to put values on things? Like, we have to try to, otherwise we can't even make a case, because some things are
How do you
priceless.
do trades?
Yeah, how do you trade something that's? Sorry, I'm going to shut up.
No, yeah, I agree with that. And the ways I think it's useful to try to get like a lower bound attempt. Like, what is the value of cultural heritage? Economists have some ways of trying to get that type of value. What is the value of dark skies tourism? Economists have studied that. I looked at a report the other day that showed, like in the Colorado Plateau, it's about $2.5 billion per year. So we can start to, okay, well, that's a value, then really a lower bound value, right? Then we can think about what the costs of that are, how much less tourism we're gonna get if the skies aren't as dark. So how can that help us though, right? It's not everything, but how can it help us make a policy decision? Well, we could make a policy decision that's that we're going to tax the size or an approximation of the cost that operators are imposing on society writ large, right? Maybe that goes into higher user fees or some sort of bond that could be rebated based on best practices. And we can, so that we can look at, oh, here was the value, or here's what the cost of doing nothing is. And so then we can start to price what that externality is and make operators internalize their decisions, and maybe they'll attenuate the amount of pollution they're creating, or otherwise we can use that revenue to help dark and quiet skies initiatives. So I agree with you, it's not everything, but it at least helps us make better policy choices.
I wanted to add in real briefly that there is a real cost to mitigations. And I think one frustration in the satellite industry is that it's not clear what mitigations will quote unquote solve the problem. So this is one thing astronomers are trying to work towards. Tony Tyson, who's the chief project scientist for Rubin, is actually hosting a workshop later this summer looking at that question. How many satellites is too many, right? Because if you have a constellation with only 2 satellites or 1, like the International Space Station, astronomers can simply track where it is in the sky and make sure they don't point at it. But when you get enough satellites where no matter where you point, there's always one that is that bright, now you have a problem, right? And so there's actually are some quantified questions that have not been answered by the astronomers. There's a lot of work that can be done. And so I think knowing that there's a real cost, especially to small startups, as David Goldman was talking about, you know, it's not something that every small startup can do. And so I think that's where it's going to be helpful is we can kind of work together towards identifying what mitigations and steps really make sense. And then are there ways that we can kind of pool our resources to all help each other so that every company doesn't have to go and reinvent the wheel with a particular innovation. And if it's a small enough constellation, for example, maybe the only mitigation is that, you know, high precision telemetry needs to be provided so astronomers can point around it. But then when there's larger constellations, that's when it's more important that the darkness doesn't exceed a certain amount if it's going to be everywhere, ubiquitous. So yeah, just wanted to point out, I mean, that's a very real problem and I think a frustration among the satellite industry that we do need to keep, you know, working together on.
Yeah, great. I saw I got a question up here. And just a reminder, if you can please state name and affiliation. So this guy right here.
Hi again, my name is Andreas. I'm a fourth year aerospace student here. I wanted to hear a little bit more about the telescope bore site avoidance. I was wondering how applicable is that to the many satellites that are already up there? And then also, is that a voluntary thing right now? And do you foresee that becoming like a regulatory requirement, either nationally or internationally?
Yeah, that's a great question. So there's a number of papers, I'm happy to point you to it in the break, that actually describe in great detail. But essentially the bore site avoidance works where the telescope, and it's different depending on the field of view of the telescope, there's an inner and an outer angle. So for the SpaceX satellites, when the transmission gets within that inner bore site, they actually turn off their transmission. When it's in the outer bore site, they actually just move the beams away so that you don't have that kind of conjunction. It currently is completely voluntary, so it's been just cooperation, which has been fantastic. And it's something that, you know, required software development at the telescopes because astronomers were kind of used to doing their own thing. So having to provide the schedule in advance in a way that's secure, that a satellite operator can ingest. And so we're actually hosting a kind of a worldwide discussion on July 1st of what sort of a standard format would be if other, you know, observatories wanted to participate in this technique. But there's, yeah, a number of papers that have explored and how well it's working. There's still some challenges and technical things to be worked out, but it has drastically improved the interference situation for telescopes.
I see a guy up here in the front. You guys on this side of the room are going to have to start asking questions at some point.
He's up there.
I'm Dan Baker from the University of Colorado. First, it's encouraging to see people from very different walks of life, so to speak, speaking collegially and civilly with one another. I hadn't necessarily expected that. But yesterday, one of the panelists pointed out that the ozone hole problem was dealt with. And I think a reason was that was an economic one, Zack, and was that there were other chemicals that could take the place of the fluorocarbons for cooling systems, and so there was money to be made. I think we're seeing that there's money to be made in the service providers, but I think there's money to be made on the other side too, to have better surface materials on satellites to reduce interference. We heard about some ideas to reduce the number of launches perhaps by having refueling. There's money to be made perhaps in debris removal. And so I don't want to go through all the economics. You guys can do that better than me. But I think we have to start to have the more attention to what is the proposition, what's the value proposition for making the situation better and not just allowing it to be driven by the service provider money. So I'd welcome comments from the panel.
I'm going to jump in without, I agree that we need to have these value propositions, and I'm not the person to make them, as is clearly abundantly obvious to everyone. I do, you reminded me of something though that I really wanted to share, because I don't know if everyone is aware of this. You're talking about the ozone. I know, Dan, you're aware of this. When we're looking at, which I think we can all agree in the near term, 50,000 satellites in orbit is not, it's not a pipe dream, right? That's happening probably pretty soon. When we look at the re-entry rates for those, and we make some assumptions about what those satellites are made of and the elements they're made of, ballpark, and I'm an astronomer, so I do a lot of ballpark estimating. Ballpark, we're looking at about 1,000 tons of aluminum vaporized in the upper atmosphere every year. Right now, it's not really a big issue, because right now the amount of aluminum vaporized in the upper atmosphere is actually, it's not that different from what we naturally get from meteorites. And so at the moment, it's not like raise the alarm bells, panic. But when we get up to 50,000 satellites in orbit, and presumably that number will go up, we're looking at significant amounts, orders of magnitude over the natural meteorite fraction, being vaporized in the upper atmosphere. And, atmospheric scientists really have not had a chance to study this. We don't know what impact it's going to have. It could be catastrophic, right? We're doing inadvertent geoengineering here without thinking about the consequences. And so I do want to raise that as something I really hope folks in industry are thinking about, because I don't think anyone here, I hope, wants to destroy the planet.
Just a very brief follow-up on what Kelsey just said, that yeah, both launch and reentry at the scale of what's happening is having atmospheric impacts, and even something as benign as water vapor put at a level in the atmosphere where that's not naturally there does create changes in chemical composition, and we don't know the consequences of that, but we do know that there are changes happening. So it's something we really need to be aware of and continue to think about.
Can you speak to the value proposition?
I don't know. I mean, we have 20th century institutions for 21st century problems, right? And we need to update this greatly, particularly like when, if Starlink represents the great vast majority of current, satellites in operation, but that's going to change. It's going to be internationally, that's going to change. So the ozone layer example is great, because the Montreal Protocol was countries coming together, right, to sign a treaty to avoid a very bad global outcome. And so that's what we are going to need again with this global commons problem. And so, whether that is amending the Outer Space Treaty or approaching it from some other way, it's going to require that international cooperation and a global understanding of what the value of taking action is, even if it is costly to firms and countries to do so.
All right, so we have time for one quick, and I see somebody that already has the microphone, so you got it. So I'll say one quick question and brief, stressing brief response from the panel.
Okay, short question. Appreciated the discussion about educating citizens about the value of dark skies, night skies. What champions do you have? Do you have caucuses on the Hill? Do you have policymakers that understand that? Do you have a radio astronomer that's actually a member of Congress? I don't know. I'm just kind of curious, how do you activate the Planetary Science Caucus? Because I know there's one in the House. I'll stop there, could add more, but because that's the community that makes so many of the policies that implicate you or impact.
I'll just speak briefly. Lindsay DeMarschi, who is not the Aerospace Corporation, had been working for Senator Hickenlooper's office, and she had actually worked on some legislation that I believe was introduced in the last session to create like a center for excellence to kind of study more in depth. So that was something that I think is still, out there. I'm not aware of any more formalized caucus, but there are folks, especially on, scientific committees that do ask questions and are interested in the topic.
Anybody else?
The one thing I think the point you're making is really important. And as astronomers who are not naturally good at these things, it's hard for us to do this. Sometimes our hands are tied because of the institutions we're affiliated with. We have to be very careful in public institutions about what we can and can't do with respect to government. So that's just an issue we have to navigate as well.
One other just quick comment, if folks are not aware, the United Nations Committee on the Peaceful Uses of Outer Space, Scientific and Technical Subcommittee, STSC, they do have a 5-year agenda item that was passed and began in February of this year on dark and quiet skies. This was led by the government of Chile and Spain. So there will be that opportunity for international discussion, sharing best practices and things at that particular forum. So did want to bring that to your attention if you were not aware.
All right. Well, if that's it, let's thank our panelists.